Hello, Donna High School. My name is Brian Villarreal, and I'm here with Mr. Castro, math teacher at Donna High School. He's going to give us a few words on a new project he's completed with a couple of his students. So, Mr. Castro, take it away.
Hello, I am Cesar Castro. I'm a math teacher at Donna High School. My goal as a teacher is to promote lifelong learning and develop student mathematical skills. In order to promote lifelong learning, I created a lesson in which students were exposed to real-life situations, incorporating science, technology, engineering, and math. The purpose of the lesson is to represent real-life situations into linear equations by having a student use a quadcopter. A quadcopter records real-time live view on your mobile device that allows you to take photos and videos. The video recorder provides a student with the distance traveled by the drone and the flight time. The engineering lesson was divided into 3 days. On day 1, I used students' prior knowledge to anchor new information. Key terms were reviewed such as domain, range, slope, and variables. To engage learners, I showed them a video clip that explained what careers use linear equations. Students were engaged by doing a foldable to summarize some of the careers that use linear equations. They were able to understand that most of the careers use algebra in their daily work, including carpenters, store clerks, architects, bank counters, nurses, doctors, and engineers. On day 2, I decided to show them what engineer does, since the student indicated on a survey that they do not know what is engineer. Later, the students start the engineer lesson by working in 3 different stations, with the goal of finding the speed traveled by the drone. In station 1, a student used their knowledge to define the variables such as slope, y-intercept, dependent and independent variable from the y-intercept form. This formula was used by students to help them solve the drone speed.
To find the slope and the problem. Y equal mx plus b. So we find this to this problem.
Okay then, thank you.
In station 2, students were required to fly the drone and record a video. The video will provide the data for station 3. The data include the time and the distance traveled from the drone. I gave to each group a different scenario. For example, the first group recorded a video from the school's library to the wrestling stadium. The second group recorded a video from the stadium to the library. And the third group recorded a video as the drone descending from an altitude of 100 feet approx. In station 3, a student used the data collected from the drone to represent the relationship among time and distance by using tables and graphs in order to figure out the speed of the drone.
They have to calculate their time and distance. They're going to get it out of the video they recorded. And out of that, they're going to have to graph it in the graph, which should be somewhere around here.
Was it 30 seconds?
After that, they're going to find the linear equation.
Do it by 2s.
By 2 seconds.
Yeah.
Or by 5.
You think we're gonna have enough for 2 seconds? So hopefully if it's 30 seconds, I think we should just do it.
So are you just estimating the distance?
Yeah, no, we're
We're gonna
estimating
figure-
the speed. The speed.
Oh, the speed, okay.
On day 3, I evaluate the students' learning by assigning to them a project. The project should include the goal of the lesson, applications, results, graph, and conclusions. Finally, I collect students' perceptions about linear equations and engineer duties by giving them a survey.
When the distance decreases is when the time increases. No, the time increases and the distance as finished decreases.
Yeah, because time is, every time the distance is decreasing because it's coming, right? Okay, thank you very much. I believe that exposing students to high level of thinking and teaching them problem-solving strategies will serve them well in complex decisions, such as those taken in school, work, or real-life situations.